All right, so let's do this. This is 8 point. The one above it. Cubes. So you guys just think about this. I did this lecture 3 times in 2 days. You know, just think about how many cubes I draw. You know, okay, for 20 years. Okay, so here's the thing. Let's say I want to put a cube here and I want to be much more precise. Or I mean, sorry, an ellipse here and I want to be much more precise. Well, I can do this. I can find the center. Now at this point, I've got 4 points. But let's say I wanted more. How could I do it? Watch. So I'm going to line this up so I have it vertical. Okay. All right.
Oh, I see what you think.
Whoops, that's not quite right. All right, so what you do, now I can actually do this, you guys, if I wanted to. I could actually just put this at a 45 and find my center. You see what I mean? It's the same thing as what I just did here. Now this is actually a hint, because then all I have to do is do this. I now have 8 points on the ellipse.
What?
I find where the diagonal hits, bring it over, bring it across, and wherever it crosses these diagonals,
I'll have like 32 point.
yeah. So does that make sense?
Yeah.
So now, do you see that with what you know now, if you know your minor is looking something like this, okay? So if you know your minor is something like this, you can really start to estimate pretty damn accurately. So where this is good, you know, where this is good is you can really, so now if I add those points, now I've actually got, you know, 12 points on the ellipse if you count the axis points. You see what I mean? So you can just sort of go, okay. Now you still want to watch your symmetry, and this is, again, you guys, I want to emphasize, this isn't really a freehand method. This is a, this isn't a freehand method. This is a method for working with your mechanicals so you can ensure more accuracy. Now, if you really wanted to, you could even add more points, you know, and transfer them all. But I'll show you something like that later. If you can, here's the thing, 8 points should be enough for something this size. Does that make sense? Now, let's say though, for the sake of argument, and I need to do this way, I normally wouldn't be this wasteful of paper, but I need to do it this way to make the point. Let's say you were drawing a big square.
Wow.
And you needed to draw a big ellipse into your sketch. And that's a pain. And let's say it's not a mechanical drawing. Let's say you're somewhere on location and there's like a giant elliptical or giant circular courtyard that you're trying to draw, okay? And you're trying to do it accurately. Okay, here's how you can do it. Watch carefully. You can start off the same way. Okay, I've got my 4 points. Okay? Now watch carefully. This may lose a couple of you guys, but watch. So I'm drawing, instead of drawing diagonally, I'm drawing to the halfway point.
It's like drawing a star.
Yeah, or the Star Trek symbol.
Oh, yeah.
Okay, but see what it does is I get these 2 points.
Oh!
Okay, and if I do this, I get these points. So now I've got 16 squares. Okay, now this is the step that used to always confuse me. So here's what I want you to think about. Make 1 equal 16 first. Okay? Then, here's how to think about it. Imagine this is 16 squares. All right? Ignore the middle 4. All right? So this next step, I'm just working with the perimeter squares. Okay? This is how to remember how this trick works. Okay? Because when I show you, you're going to go, oh! All right? But then when you get home, you're not going to remember how to reconstruct it. If you forget, if you start thinking it involves these squares, you're going to get confused. Just think of these perimeter squares. And I'm actually going to draw this larger. What you're doing is you're doing this. Imagine you've got one set of 4 squares. Okay? I want you to do this. And mark that point. And I want you to do this. And mark that point. Okay? Now, actually everyone keep your eyes up. So if you understand this, this is the trick of the entire diagram. Now everyone just keep your eyes up for the next minute and watch me do this. Eyes up. Eyes up. Okay. Okay. Wait for it.
That's our clap.
Do you see the dots?
Oh
my God.
It's perfect.
You see what I mean? So this is a 12-point method, but I'll be honest with you, I almost never use it. Because the only time I really find it necessary is with huge ellipses. And with huge ellipses, they really don't crop up that often. Usually they're in their picture smaller. I mean, where they crop up is if you're doing a sketch of Saturn. And it's going across your, the ring is going across your entire picture. Then you have a huge ellipse. Very seldom, though, when you think about it. You have ellipses going way across everything. Does that make sense though? It's a good on location trick, but it's not really something. Rather, if I'm doing a mechanical, you guys, if I'm doing a mechanical, I never use this method. If I'm doing a mechanical, I use this method because it's more precise. Okay? Does that make sense? Yeah.
I have a question. Like, is the sphere related to this?
Yes.
So like the sphere has perspective too.
All right, you guys, this is a bonus diagram. I'm going to do it really fast, and then we're going to do it for real on Wednesday, okay? You ready? Yeah, I'll do it. I'll slow down it. I'll slow it down on Wednesday, but watch this.
It's just a parabola.
I do that, sir.
Oh,
It's
God.
Kermit.
Is that cross?
That's creepy.
But you guys, it's all understanding ellipses and spheres, you know. But really, the ellipses, I'm sorry, the spheres are not. You know, here's the thing. This is a stupid one. I felt kind of bad for the guy, but it was too funny. So I was doing this whole thing on ellipses all day, and this is at the academy, where the students have more money than brains. Yes, I don't know. No, just kidding. That's me. Okay. Anyway, the guy was a good student, but he's sitting there and he goes, "We'd been talking about ellipses. Okay, John, but how would you draw a sphere in perspective?" And I said, "Think about it." And I turned around and I'm working, and all of a sudden it was, oh, because, you know.
No matter what.
Now that's a little unfair, though. That's a little unfair, actually, because we are going to get into drawing spheres in perspective and kind of some of the mechanical stuff you need to know, because if you're drawing an object like this is a spherical spaceship, let's say, and you've got an object, you've got something coming off the side of it and then casting a shadow. You need to know how to do that. And it's evil. Or for instance, if you have something like this, let's say you have something like this and you're looking down on the sphere at that angle and say, you know, this is the shadow that's being cast. Well, let's say I ask you to put something coming out the exact top of it, like it's an umbrella, let's say, and you need to have the thing coming right out the top. Well, where is the top? It's not here, because that's on the back side. You see what I mean? It's actually right about here. But there's a way to calculate that that's brilliant, right? I was showing it to Alan. It's like brilliant, you know. Anyway, all right. A couple other things I got to do real quick. So the 12-point and the 8-point thing, if you need more detail, that's how you can do it. If you need to be tighter mechanically, use I would recommend this method generally, using a measuring, like for your mechanicals. When you guys are working on your mechanicals, you want to use measuring lines and a compass and do it that way. That's how to do it. Now, once you've got all those points in there, then you still plot out your major and minor, and you still watch your symmetry. You know, that's what's going to allow the ellipse to look good. But this is going to give you all the points you need to hit, okay, with that ellipse. All right?